All right, okay, so today we are going to discuss the Boolean laws, right? So when it comes to the Boolean laws, first we have the idempotent law. So here, what does it mean? So basically here they have mentioned A dot A is equal to A. A dot A is equal to A. Now here A is one input, right? So here we have if there is one input, 2 to the power 1 is going to be 2, where there are going to be two combinations. One is going to be 0 and the other one is going to be 1, right? So then we are multiplying A dot A by A, right? So A dot A, here you can see 0 into 0 is going to be 0, then see 1 into 1 is 1, right? So here we are using that. So it's clear for us that A dot A is going to be equal to A. A dot A is equal to A. Then here, if you consider this scenario, A plus A is equal to A. Now here we have one input. So if there is one input, 2 to the power 1 is 2, where two combinations are possible, where it's going to be 0 and the other one is going to be 1, right? Then A plus A, right? So 0 plus 0, 0. 1 plus 1 is going to give you 1. 1 plus 1 is going to give you 1, right? So then here, once you consider this scenario, A bar dot A bar is equals to A bar, it seems. So first here, also we have one input where it's going to be A. So if there is one input, 2 to the power 1 is 2, where two combinations are possible. One is going to be 0 and the other one is going to be 1, right? So here, then opposite of A is going to be A bar. So here 0 means the complement is going to be 1, opposite. Here 1, A is 1, so the opposite is going to be 0. Then you are going to multiply A bar dot A bar. 1 into 1 is 1, 0 into 0 is 0, right? So similar to AND gate. So where it proves us that A bar dot A bar is equals to A bar, right? A bar. Then here, once you consider this scenario, A bar plus A bar is equals to A bar. Now here we have A, where 0 and 1 are there. Then here we have A bar. So A bar means the opposite here, the complement, right? So here we have 0, the A bar is going to be 1. Here if we have 1, the opposite is going to be 0, right? Like NOT gate, we have studied. Then A bar dot A bar, you are going to A bar plus A bar, you are going to add or right, or logic. So 1 plus 1 is going to give you 1. 0 plus 0 is going to give you 0. So here it's proved that, now look here, this A bar plus A bar's final result and this A bar's final result, right? Both are same, isn't it? That's why it is said A bar plus A bar is equals to A bar. So I hope this is clear. So when it comes to idempotent law, how can you simply remember this? Now here, if you add or multiply two, right, two same letters, right, you can write only one letter. For an example here, A dot A, A dot A, both are same letters. So you can write only one out of them. Only you can write A. So that is one of the shortcut way to remember this. Now A bar dot A bar, both are same. So you can write one out of that, A bar, right? So this is one of the shortcut method to remember the idempotent law. And we have proved this using our truth table, right? So moving forward to the next law, dear students. In the next law, we can see identity law. Now, what does this identity law? Now, don't worry about laws, right? So watch this video until the end. So it's going to be crystal clear for you guys, right? So identity law, what does it mean? Here we have 1 dot A is equals to A. Now we have A, right? Now if we are having A, we are having right? So 2 to the power 1, right? So 2 to the power 1 is going to be two combinations, right? One is going to be 0 and the other one is going to be 1, right? So here 1 is going to be constant here. So here also 1 dA, here also 1. Now here for A, 1 is going to be 0 and the other one is going to be 1. Then 1 dot A. So 1 into 0 is 0, 1 into 1 is going to be 1, and logic. So that's how, now you can see that the output. Now look here, 1 dot A's result which is 0 and 1, and see this one. Now highlighted columns both are identical. So this proves us that A dot A is equals to A. Clear? So let's move on to the next one. Um, 0 plus A is equals to A. 0 plus A is equals to A. Now here the 0, this in this truth table, the 0, the both the values is going to be constant. So here we are going to get 0, and for A we have one input. So 2 to the power 1 is 2. So two combinations are possible. One is going to be 0 and the other one is going to be 1, right? Then here we are having 0 and here we are having 1. Then 0 plus A, right? So 0 plus A, you are going to use the OR logic. So 0 plus 0 is going to bring you 0 here, 0 plus 1 is going to bring you 1 here. Now you can see that these highlighted columns, which are 0 plus A and A, are both are the same. So that's why according to the law, 0 plus A is equals to A. Okay, dear. Right. So next move on to this one. 0 dot A is equals to 0. Now in this case also the 0 is going to be constant. So for both here combinations we are having zeros here. And for the A, for one we are having 0 and the other one we are having A. Then 0 dot A, the AND. So 0 into 0 is 0. 0 into 1 is going to be 0. So 0 dot A is equals to 0. What does it mean? Now here you can see that the highlighted columns, right? Look here. Here also we have 0, 0 here. Here also we have 0, 0. So both are same. So that's how this logic is proved that 0 dot A is equals to 0. Okay. Then let us move on to this part now. 1 plus A is equals to 1. Now, in this case, for this truth table, for this one, now both the values here are going to be constant, right? It's not changing. For A, it's going to be 0 and 1, right? 0 and 1. So then 1 plus 0 or is going to be 1 and 1 plus 1 is also going to be 1. So I think that's clear. So that's the identity law here. Then let us go to the next law, inverse or complement law. Inverse or complement law. Now here we have two forms. One is the multiplicative form and the other one is additive form. When it comes to the multiplicative form, we have A dot A bar is equals to 0. A dot A bar is equals to 0. Now here we have for A, one input is going to be 0 and the other one is going to be 1. What is A bar? The not the complement, the opposite of that. So for here, if you are having A, here for A bar will be having 1. And for here, for A, if you are having 1, for the A bar you are going to have 0. Then A dot A bar. So 0 dot 1 is going to bring you 0. 1 dot 0 is going to bring you 0 and logic, right? So when it comes to the additive form, A plus A bar is equals to 1. For A we have 0 and 1. So for A bar it's going to be the opposite, the complement. So dear, here if it is 0, here it's going to be 1. And here if it is 1, here it's going to be 0. Simple as it is. Then A plus A bar, right? Or so 0 plus 1 is going to give you 1. 1 plus 0 is going to give you 1. Now you can see that A plus A bar, where this 1 and is equals to 1, right? This one is equals to 1. So that's what it has been proved here. Then here you can see that A dot A bar's the result is equals to 0. Is equals to 0. I think it's clear, right? So then De Morgan's law. Now this De Morgan's law is one of the very important law when it comes to final examination, your advanced level examination ICT, right? So we have two forms here too. One is multiplicative form and the other one is the additive form. Multiplicative form. A dot B whole thing bar. A dot B whole thing bar. Now dear, if I ask you a question, if there is a bar at the top, if there is a bar at the top, what does it mean? Opposite, no dear, opposite, no. So now look here, when you simply understand, try to understand this without the truth table. Now here you are having dot, right? You are having dot. So what is the opposite of dot? Plus, no. So then if this bar is broken, if this bar is broken, right? So this you have a dot here. So as because of the bar, the dot is going to become plus. Why? Opposite no, once you apply a bar. That's why here it's plus, because the dot has been converted to plus, and here it's going to be a bar plus b bar. I think it's clear. So let's go through the truth table also. Now AB, two inputs are there. So 2 to the power 2 is 4, right? 4 combinations are possible. The first one is 0, 0 dear. Second one is 0, 1. Third one is 1, 0. And fourth one is 1, 1. Then what does AB means? A into B. 0 into 0, 0. 0 into 1, 0. 1 into 0, 0. 1 into 1, 1. And logic. Okay, dear. And logic. A dot B whole thing bar. A dot B whole thing bar means the opposite of AB is going to be A dot B whole thing bar. So here 0 means here it's going to be 1. Here 0 means here it's going to be 1. Here 0 means it's going to be 1. And here 1 means it's going to be 0. Then we are taking considering only the A bar. Now here we are having 0. So here it's going to be 1. Here we are having 0. So here it's going to be 1. Here we are having 1, it's going to be 0. Here we are having 1, so here it's going to be 0. Then B bar, opposite of B. So 0 here means 1 here, 1 here means 0 here. Likewise, for the remaining two also you can fill it. Then A bar plus B bar. Then you need to use the OR logic and add both of them. So 1 plus 1 is going to be 1, 1 plus 0 is going to be 1, 0 plus 1 is going to be 1, 0 plus 0 is going to be 0. Now look here, A bar plus B bar. And look the A bar plus B bar, and look A dot B whole thing bar. What? Both are same, right? Both are same. So that's what this multiplicative form of De Morgan law says, that A dot B whole thing bar is equals to A bar plus B bar, right? So simply how I taught you. So if there is a bar at the top, this dot is going to become plus. Why? Bar means opposite, right? Multiplicative form done. Let us move on to the additive form and try to have a brief and a good and a deep understanding on that, right? So additive form of De Morgan's law. A plus B whole thing bar. Now before we had a dot, and because of the bar it became plus. Now here we are having plus, because of the bar it's going to be dot. Yeah, opposite. So A bar dot B bar, A bar dot B bar. This is the simplest and easiest way to remember this law, right? So let's move forward. A, B, we are having two inputs. Two inputs means 2 to the power 2, 4 combinations are possible. We are 0, 0, 0, 1, 1, 0, and 1, 1. A plus B, use the OR logic. So 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 1, right? Then A plus B whole thing bar means the opposite of A plus B, guys. So here 0 here means here it's going to be 1. 1 here means it's going to be 0. 1 here means it's going to be 0. 1 means 0. A bar. A bar means what? Opposite of A. So here we are having 0. Here it's going to be 1. Here we are having 0. Here it's going to be 1. Likewise, right? So here for the remaining also you do. B bar. B bar, how B is 0 means B bar is going to be 1. Now here you have B1. For the B bar it's going to be 0. Like that for the remaining also you can do. Now when I am saying what you need to do, take a piece of paper or a book and do with me itself, right? When I am saying, so it is going to be clear, it's going to be more clear for you guys, so you must do that, right? So from your end, right? So A bar dot B bar, then we need to use the AND logic and multiply. So 1 into 1 is going to be 1, 1 into 0 is going to be 0, 0 into 1 is going to be 0, 0 into 0 is going to be 0. Now look here, A bar dot B bar here, and look the A plus B whole thing bar, both are same, right? So that's what this additive form says. A plus B whole thing bar is equals to A bar dot B bar, right? Done. We are done with the De Morgan's law as well. Double complement law. Double complement law. Now A is equals to A double bar, it seems. How can I explain this more simply for you guys without the truth table? Now let me say like this. Let me say X is equals to 1. X is equals to 1, okay? X is equals to 1. Then how much will be X bar? How much will be X bar? So opposite of X is X bar. Then X bar will be 0. Now for that 0, now X bar is 0 now. So if I put a bar top of that, Opposite of 0, no dear, then it's going to be 1. That means what? X double bar is equals to X. Understood? So that's what here also it's stated. A is equals to A double bar. As simple as it is, right? So 0 here we are having. Then here we are having 1, right? We are having 1. So here A bar means opposite. So 0 means here it's going to be 1. And 1 means it's going to be 0 here. Then A double bar is opposite of A bar. So 1 means it's going to be 0 here. 0 means it's going to be 1 here, right? So now you can see that A, we have 0 and 1, and for A double bar also we have 0 and 1, right? For A also we have 0 and 1, and for A double bar also we have 0 and 1. So this is what this double complement law, which says A is equals to A double bar, right? A is equals to A double bar. Right, good. Then next, let us move on to the next law. Next law. Right. Commutative law. Now here we have two forms, right? One is the multiplicative. One is we have the multiplicative form. Here also we have two forms. One is multiplicative form and the other one is additive form. Now multiplicative form says AB is equals to BA. Correct? Now you and me and you. Anyhow you say it's the same. All right. So AB is equals to BA. So here AB we have two inputs, so 2 to the power 2 is going to be 4 combinations of 0, 0, 0, 1, 1, 0 and 1, 1. These are the 4 combinations. So AB means A dot B, 0 into 0 is 0, use the AND logic, 0 into 1 is 0, 1 into 0 is 0, 1 into 1 is 1. B dot A, 0 into 0 is 0, 1 into 0 is 0, 0 into 1 is 0, 1 into 1 is 1. Anyhow, look here, here also you are getting the same result. Here also you are getting the same results. I and you and you and I. I and you also same, you and I also same. So that is the commutative or multiplicative form. Very clear, I think. So additive form, this is also same, right? So A plus B, B plus A, right? Even you say like A plus B is also same, B plus A is also same, right? Anyhow, it's going to give the same result. So here we have two inputs. So 4 combinations are possible: 0, 0, 0, 1, 1, 0, and 1, 1. Right? Very simple. So here A plus B, use the OR logic. 0 plus 0 is going to give you 0. 0 plus 1 is going to give you 1. 1 plus 0 is going to give you 1. 1 plus 1 is going to give you 1. Then B plus A. So 0 plus 0. Anyhow, it's same, no dear. So 0 here, 1 plus 0 is going to give you 1 here. 0 plus 1 is going to give 1 here. 1 plus 1 is going to be 1 here. So that's what it is stated. A plus B is equals to B plus A, right? I think commutative law is also clear. Associative law. Now here we have two forms. One is, here also we have two forms, multiplicative form and the additive form. Let us first look into the multiplicative form. A bracket BC is equals to AB, A bracket bracket AB and C, right? So what does it mean? A within brackets we have BC, then equals to within brackets we have AB and outside C. So ABC, so 3 inputs are there, means 8 combinations are possible. How it's going to be 0, 0, 0, 0, 0, 1 like given in this truth table. Then B dot C, use the AND logic, B dot C. So 0 into 0, 0, 0 into 1, 0, 1 into 0, 0 like that. For the remaining also, you guys can fill. Then A dot B, so 0 into 0 is 0, 0 into 0, 0, 0 into 1, 0. So for remaining also, you guys can fill. Then this A and this BC you need to multiply. So here 0 into 0, it's going to be 0. 0 into 0 is going to give you 0. 0 into 0, here it's also is going to give you 0. Like that you can multiply for the remaining also. Now for last one here, 1 into 1 is going to give you 1, right? So here the next one, AB. So within brackets we have AB and you need to multiply it with C. So 0 into 0 is going to give you 0, right? Then here 1 into 0 is going to give you 0. Like that for the remaining also you guys can try. I will explain the last one. Then here 1 into 1 is going to give you 1. AB, no, AB means this one, and C means this one. So 1 into 1 is going to give you 1. So this proves that A bracket BC is equals to AB cross the bracket C, right? So that's what it is stated here. Associative law multiplicative form A within brackets BC is equals to AB, which is within brackets, then C outside the brackets, right? So done. Then we'll come to the additive form of the associative law, right? So here we have A plus, within brackets we have B plus C, that is equals to A plus B within brackets plus C, right? So here 3 inputs are there, so 8 combinations are possible. Like I explained before, B plus C. So you need to use the or logic and add both of the 0 plus 0 is 0, then 0 plus 1 is 1. Like that, you can fill for the remaining ones also, because I have explained the how to do this in the before example. So A plus B, so 0 plus 0 is going to give you 0 here, 0 plus 0 is going to give you 0 here. For the remaining also you can do. Then A plus, within brackets we have B plus C. That means you need to use the OR logic and add A plus B plus C. So 0 plus 0 here is going to be 0. Then here you have 0 and here you have 1. 0 plus 1 is going to give 1. Then within brackets we have A plus B, which is this, and you need to add that with C using the OR logic. So 0 plus 0 is going to give you 0. Then here 1 plus 0 is going to give you 1. So like that, once you fill, you can prove that A plus within brackets B plus C is equals to A plus B within brackets plus C, right? So I think that is also clear. So we are done with the associative law as well, right? So now we are moving to the next law, which is the distributive law. Now here this is very simple, right? So even I don't need to refer the truth table directly. I can say right. So A B plus C. So remove the brackets and multiply. So A B plus A C. So A within brackets B plus C is equals to, remove the brackets and multiply, A B plus A C. So 3 inputs are there. 8 combinations are possible. Then B plus C, you take the output. So 0 plus 0 is going to be 0. Then A plus B, sorry, A dot B, 0 into 0 is going to give you 0. Then A dot C, 0 into 0 is going to give you 0. Like that for the remaining, these ones also you guys need to fill. Then A, B plus C, B plus C means this one. You need to multiply this with the A, right? So 0 into 0 is going to give you 0 here. Then interesting, then here 0 into 1 is 0. That's how you need to do for the remaining ones as well. Then AB plus AC. So you need to simply add AB and AC. 0 plus 0 is 0, 0 plus 0 is 0, 0 plus 0 is 0. Like this one and this one. Like that you can do for the remaining ones also. That is distributive law. Redundancy law. Now this redundancy law is very important, right? So we have here we have form 1, which is A plus AB is equals to A. What does it mean? A plus AB is equals to A. Now look at the here the truth table, right? A and we have B. So 2 inputs are there. 2 to the power 2 is 4 combinations are possible. So first one is going to be 0, 0. Then next one 0, 1, 1, 0, 1, 1, likewise, right? A dot B, A into B. So 0 into 0 is going to give you 0. 0 into 1 is going to give you 0. 1 into 0 is going to give you 0. 1 into 1 is going to give you 1. Then A plus A dot B. That means this one you need to add with this one. So 0 plus 0 is going to give you 0. 0 plus 0 is going to give you 0. 1 plus 0 is going to give you 1. And 1 plus 1 is going to give you 1. Now look here, guys. So A plus AB, this one, and A. Aren't they same? They are same. They are same. So that's why it is stated A plus AB is equals to A. A plus AB is equals to A. That is the first form. Then the second form states that A plus A bar B is equals to A plus B. How? A plus A bar B, A plus A bar B is equals to A plus B. Two inputs are there, four combinations are possible: 0, 0, 0, 1, 1, 0, and 1, 1. Then A bar means, guys, already we have taught everything I have taught. So 0 means opposite 0, the opposite of 0 is 1. Here we have 0, the opposite of 0 is 1. Here we have 1, opposite is going to be 0. Here also 0. Then A bar dot B. This one you need to multiply by this one. So 0 into 1 is 0, 1 into 1 is 1, 0 into 0 is 0, 1 into 0 is 0. A plus A bar dot B. That means this one and this one you need to add. So 0 plus 0 is 0. 0 plus here 0 and 1. 0 plus 1 is going to give you 1. Then 1 plus 0 is going to give you 1. And here finally 1 plus 0 is going to give you 1. Then here A plus B. A plus B. So let me erase some of these to me. So it's going to be visible clear for you people. Then here we have A plus B. So 0 plus 0 is going to be 0. 0 plus 1 is going to be 1. Here we have 1 and here we have 0. So 1 plus 0 is going to give you 1 and 1 plus 1 is going to give you 1. Now you can see that A plus A bar dot A plus A bar dot B, which is this one, right? A plus A bar dot B is equals to A plus E, right? Both are same. That's what it has been proved in the redundancy law form 2, which is stated as A plus A bar dot B is equals to A plus B, right? A plus A bar dot B is equals to A plus B, right? Now we are done with all the laws in the advanced level relevant to this Boolean laws, where we are done, guys. So what I wanted to do under these Boolean laws, so let us try some examples, right? So let us try simplifying logic expressions using Boolean theorems, right? So here you have the example number 1, Q equal ABC plus A bar BC plus ABC bar. Now you guys, what you need to do, don't look at the answers, or don't wait until I explain. Try it by yourself by pausing the video, and after trying it by yourself, check whether you are getting the correct answers. Right now I think you have tried, so I'm going to explain. Now here, now ABC. So let us bring this ABC bar this side, and let us take this A bar BC this side. Now if you consider these two, right, which is common? A bar AB, right? AB is common. AB is common. So let me take the AB out. Let me take the AB out because they are common. So once I take the AB out, so we can see C, and this C bar will become C plus C bar. What is C plus C bar? And this A bar B C will be there, remain as it is. So this is what is the law? Distributive law. So simply what did I do? Here also you have AB. Here also you have AB common. So I took the common out. So C and C bar will remain, right? Then plus A bar BC. This is the distributive law. Then students, now next what I did was, right, so here we know C plus C bar is equals to what? 1. C plus C bar is equals to 1. I have taught the law, that is inverse law. Inverse law. So within AB within brackets 1, then plus A bar BC, right? Plus A bar BC, that will remain as it is, right? So then moving forward to the next step, we are done with this. Now AB dot 1 is equal to AB. AB dot 1 is going to be equals to AB plus A bar BC. So that is also you can see distributive law. That is distributive law. The next one, now here what is common? Now here we can see that B is common out of both of these two. So let us take the B out using the distributive law. Then once you take the B out, here you will be getting A, and here you will be getting A bar C. So what is the law? Distributive law. Then we can see we have B. B will be like that. Then A plus A bar C is going to be A plus C. Now just now we learned that A plus A bar B is going to be A plus B. Now here it's A plus A bar C. It's going to be equals to A plus C. What is the law? Redundancy law. So this is the final simplification. We are done with that. So let me explain another example also for you guys. So f is equals to c plus b c whole thing bar. Now c plus, now this can be broken b bar plus c bar. What is the law? De Morgan's law, which I have explained you. Then c plus, let us bring the c bar this side and let us take the b bar that side, right? So then we can see c plus c bar is going to be 1 plus b bar. What is the law? Inverse law. C plus c bar is going to be 1. Law is inverse law. Then 1 plus b bar is going to be is equal to 1. That is the identity law. So guys, I think the Boolean laws is clear for you. So now you guys can try the other questions even in your past papers. You can try it by yourself by simplifying the simplifying logic expressions using the Boolean theorems.